So we continue on our our explanation for the first chapter, railway planning, and we have reached section 3 where we are talking about railway safety management. And in order to understand this in more details, we talked about different topics until we reached the topic of railway safety and complexity. And we will discuss this topic in more details now. So this is the content of the chapter. We talked about understanding risk matrix, human error, and now we'll be talking about railway safety and complexity, and we include that safety requirements and defense mechanisms. We include this until we reach examples of railway accidents. So this is railway safety and complexity. And to understand the railway as a system, we talked that this system consists of subsystems that interact with each other. However, this system has a group of characteristics that define it from other systems. The railway system is complex because it has 4 complexity dimensions, and those can be gathered in what is known as the butterfly of railway complexity. And it's good illustration to try to help you think about the railway complexity and how different components interact. The railway is a variable system. It has variability in terms of physical variability, in terms of there is different ground parameters, there is different organizations that is running the railway. So it's a variable system. It's a dispersed system. So there is dispersion of the railway assets. It's a diverse system, and we are talking about components and how these components have different parameters and have different characteristics also in terms of organization, but also the railway has this interdependence. So we talked about variability, dispersion, diversity, and interdependence. Those concepts help you to understand the railway complexity, but how we can manage railway safety in such a complex system. So let us look about risk. Can we control all types of risk, or can we control the most important risks? So to do that, you really need to think about risk classification. So many people think about that absolute safety is impossible. So it's very hard to have that 100% safe system. Most probably this system is not operational because there is no interaction, and so there is no incidents. So we need to think about risks as acceptable risk and unacceptable risks. And acceptable risk might have a very low cost, like a passenger sleeping in a station, or it can have a very low frequency, like an earthquake in an area where earthquake does not happen at all, or they did not happen for the last 100 or 50 years. So that low frequency or low cost define what is an acceptable risk is. But it's not only you need to think about what kind of risk is acceptable, what kind of risk is not acceptable in such a complex system, but you really need to think about stakeholders. And when we talked about systems engineering before, we need really to understand stakeholders. So for safety stakeholders, you need to guarantee safety for the traveling public, for those people who are using your trains, or for the people who are using your infrastructure or station. You need to think about safety of track workers. And by track workers, we need anyone who is responsible for the maintenance. They can be the welders, the inspectors, the engineers. You need to have these safety rules. You need defense mechanisms that make sure that track workers are safe while they are working. Also, you need to think about safety of operational staff, the dispatcher, the driver, the station staff, the people who work at the control centers, and any other one who's involved in train operations. It's not only that, but also you need to think about third-party safety issues, people who are not from the operator or the infrastructure owner, but can be affected of railway safety. Can be like the people who are living beside the railway line, or any other people that you might be thinking about. So we talked about acceptable risk and unacceptable risk. We talked about transport system safety stakeholders. And to understand this in examples. So for example, safety of traveling public, like safety of traveling passengers, you need to think about accessing trains, and you need to think about riding trains. You need to make sure that those people have safe access to trains. So for example, when we talk about what is the height of what is the height of the train access. So some people say lower, they do lower access for disabled people, or they do disabled people access so elderly people can use, and sometimes they use this ramp. So there is safety for traveling passengers, and it's very, very interesting how many people have been thinking about this, that sometimes I have seen this many times, like in the UK, if you are a disabled person on a wheelchair, they would put the ramp for you to ride the train. And there is the second thing is safety of operating personnel, the people who are operating trains, handling goods, dealing with incidents. For example, if you have a problem with your overhead line and you had an electrified ground, it's very much important that you make sure that those people who are going to fix this problem are safe, and you do the right isolation measures to make sure that the fixing process goes smoothly and as safe as possible. Also, safety of trackside workers. And by trackside workers, we talk about inspectors, we talk about welders, and any people who are involved in the maintenance. And they can also be working in depots. Like imagine that you are working on a laving machine, or you are working with trains, and one of those trains part fell, like an axle. This can really cause a serious incident. So you need to make sure that their safety is being followed, but not only for people and workers in maintenance and passengers, but also sometimes for structures. You need to make sure that the structures are safe, the trains can pass underneath bridges and tunnels safely. So now we understood the railway complexity, we talk about stakeholders, we talk about what is acceptable risk and what is unacceptable risk. We need to think about defense mechanisms. And if you remember before, when we talk about understanding risk, we talked about hazards, what causes those risks, and consequences. What are the losses that will emerge from those risks happening? And between them, there is those defense mechanisms that you really need to defend, that you really need to make sure that those defense mechanisms are being put in place to prevent losses. And an example of a defense layer is planning and scheduling. So for example, if I want to do railway welding, I would make sure that I plan that. And based on this planning, most probably you would have less accidents. Also, you would need to follow rules and regulations. Rules and regulations are one of the famous examples of defense layers. You need to have a PTS to access the track, person track certificate, or person track safety certificate, or you need to wear safety shoes, or you need to wear gloves or eye protection. So you need to make sure that you follow the rules and regulations. Management, you should have a supervisor with you if you go to the track, and supervision and control, you have someone that is more experienced, that have more experience, and this experience is proven. Training and education, and sometimes automation. Of course, there are much more defense mechanisms, such as designing the systems to be safe, designing the systems to fail safe, and many more. But what is important is to understand the concept of hazards, losses, or hazards consequences, and those defense layers that you are putting within a complex environment that many stakeholders are involved in. This theoretical framework is fundamental for you to be thinking about railway safety in a acceptable and progressive way. So one of the ways that is being practiced in reality is to get an independent third party, and one of the examples here is mentioned to Freeland. So they would do safety cases for you. They would make sure that they develop the different safety cases of the system, and make sure that you have considered the different safety cases and the different safety scenarios. They might do vehicle acceptance body. They might act as a vehicle acceptance body, and this is for trains or cars. They would give you this certificate that this car is safe and that different systems was tested to be safe, and the overall system has been tested to be safe. They also can be acting as notified body, and they can provide services such as independent safety assessment, independent competent person. And by that, they have an organization or a team that is always going to a project and making sure that they collect different evidences that this project is built to be safe and according to standards, and they provide a significant input to improve safety, and finally they issue a certificate to saying that this system is safe, and we certify it. We have certified for safety. Of course, there are other ways of managing safety, such as safety management systems and audit arrangements. Audit arrangements is part of what an independent safety assessment, ISA, what is independent safety assessment, would consist of a group of audits or an independent competent person. So this is managing railway safety and its complexity. In the next section, we'll be talking about railway accidents. So this is examples of real railway accidents that have happened, and we'll try to understand them in more details. So see you in the next section. Have a great evening.